Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 5.3, Problem 8. This is Section 5.3, Problem 8, and it says, Jen just got hired as an administrator for a large corporation. She signed a 3-year contract for a salary of $6,000 per month. How much does the corporation have to invest now at 12% compounded monthly in order to pay Jen's salary? How much will they save by investing the money at the beginning of the 3-year contract as opposed to just paying as they go? So this is a present value of an annuity. It's paying a salary. The present value of an annuity formula is A equals P times some fairly big brackets. The top of the brackets, or numerator of the brackets, has 1 minus 1 over, in parentheses, 1 plus r over m, close the parentheses, to the m times t power. And in the denominator of the brackets, you have r over m. So we'll fill in that formula. That'll give us A equals, P is the regular payment. So for this particular problem, it's $6,000. That's the regular payment. Times the brackets. And in the numerator of the brackets, we have 1 minus 1 over, and then in parentheses, 1 plus r over m. So the r is the rate as a decimal. So the rate for this problem is 12%, and as a decimal, that would be 0.12 over m, and m is the number of payments per year and also the type of compounding. So this is monthly compounding, monthly payment, so m is 12. Close the parentheses, and it's to an exponent of m times t. So m, again, is 12 for the monthly payments and monthly compounding. And t is the number of years. So this problem, t is 3. It's a 3-year contract. So the exponent m times t is 12 times 3. And in the denominator of the brackets, r over m again. So 0.12 for the r, the rate as a decimal, and 12 for the m, the type of compounding, and the number of payments per year. I'll close the brackets. And to start this really going, once it's filled in, I have to deal with the parentheses first. So let me clean up the parentheses in the formula. When I do, I will have A equals 6,000 times, in some brackets, 1 minus 1 over. So I have 1 plus r over m. The r over m is 0.12 over 12. That's 0.01. And again, if you don't see it easily, just with your calculator, enter the top, which is 0.12, divided by the bottom, which is 12 with no decimal. The calculator will tell you it's 0.01. And there's a plus 1 in front of that. So 0.01 plus 1 makes, in the parentheses, 1.01. And the exponent on that, 12 times 3, is 36. And in the denominator of the brackets, I have 0.12 over 12, which is also 0.01. So to continue, I'm going to do the 1.01 to the 36th power. And that's the next thing I have to do. So A, the amount, equals 6,000 times, in brackets of 1 minus 1 over the result of 1.01 to the 36th power, which is 1.430768784, and in the denominator of the brackets, 0.01. Close up the brackets. So in my brackets, in the numerator, I have 1 minus a fraction. I want to simplify the fraction being 1 over 1.43076874. So I'll do the division. Again, with my calculator, there's a 1 over x button that I can press, which most calculators do have. And I'll have A equals 6,000 times the brackets. And in the top of the brackets, I'll have 1 minus 0.6989244949. And in the denominator of the brackets, 0.01. So let me do the subtraction that's in the numerator of the brackets. I'll have A equals 6,000 times, in the numerator of the brackets, I'm going to do 1 minus 0.6989244949, which will give me a result of 0.30107505, and in the denominator, 0.01. So now the brackets that I've been using just have a division in it, 0.301075505 over 0.01. The 0.01 should just pull the decimal over 2 positions, same digits, but with a decimal in a different spot. That'll give me A equals 6,000 times, in the brackets I'm just going to have one number, and I'll just verify that on the calculator. And that is what happens. I get 30.10750504. The calculator has a little bit of room. It puts in a couple extra digits for me. And now to finish it, I'm just going to multiply the 6,000 in front of the brackets times the 30.10750504 that's in the brackets. And the calculator gives me an answer of 180,645.0302. So now that I have my final answer, I don't want 4 places after the decimal point. I want 2. So the 0.030 something is just going to chop it at 3 cents. So the answer to this problem, or the first part of it, how much money does the corporation have to invest to pay Jen's 3-year contract, is $180,645.03. Now the second part of the question is, how much do they save by having the $180,000 and something dollars up front as opposed to just paying every month? Well, how much are they going to pay Jen? They're going to pay her $3,000 every month for 3 years. Now there's 12 months in a year, so 3 years they're going to pay her 36 months times $6,000 each month. So if we multiply that out, we're going to do 36 times 6,000 is $216,000. So over the 3 years, Jen will earn $216,000. And they're going to be able to pay her that by only having $180,000, or a little bit more, $180,645.03. So let me subtract those two values. Let's see. And the savings to the corporation, if they have the money up front, is $35,354.97. So they're able to save that just on one employee. If they do this for many, many employees, it's very significant, the amount they can save by using the present value of an annuity.